1 of test 1. The question is, write an algorithm flowchart to solve the following pair of equations for x and y, given the values of the variable a11, a12, a13, a21, a22, a23. And the given equation is a11 x1 plus a12 x2 equal to a13. And the second equation is a21 x1 plus a22 x2 equal to a23. Given the following cases, case 1, case 2, case 3, case 4, we have to solve the following questions. Question number 1. Comment on results of case 1 and case 2 when there is change of 0.001 in one of the coefficients. And the question number 2 is how interchange of equations affect the solution in case 3 and case 4. First, we will look at question number 1, that is A, comments on the results of case 1 and case 2. So in case 1, we will use the Gauss elimination method. The augmented matrix which we will get is now with the help of above matrix, converting the augmented matrix into diagonal matrix using 2.500 as the pivot point. Then we will perform the following operation on the matrix, that is R2 minus R1 into A21 upon A11. Following the operation, we get this is the matrix which we will get after performing the following equation. Now using forward elimination phase. Using the forward elimination phase, the equation we will get will be 2.5000 x1 plus 5.2000 x2 equal to 6.2000. Now solving the equation from the second, using the second equation, 292 x2 equal to 0.04952. From here we will get the value of x2, that is 0.04952 upon 0.00292. That is x2 will be 16.9589. This is the value of x2 which we get from the solving the second equation. Now using the value of x2 to solve to get the value of x1, we put the value of x2 in the first equation, that is 2.5000 into x1 plus 5.2000 into 16.9589 equal to 6.2000. Solving the equation, we will get the value of x1, that will be equal to minus 32.79451. This is the value of x1 which we will get after solving the equation. So this is the case 1. Now we will look the case 2. In case 2, these are the following variables: a11, a12, a13, a21, a22, a23. Now using these variables, we will solve the equation for case 2 and obtain the value of x1 and x2. The given matrix will be the same, that is 2.5000, 5.2000, 6.2000, and 3.152, 1.251, and 2.606. This will be the equation. This will be the augmented matrix for case 2. By Gauss elimination, as we have done in case 1, we will perform the following operations on R2, that is R2 minus R1 upon into A21 upon A11. Now converting the augmented matrix into diagonal matrix with the help of 2.500 as the pivot. We will get the next equation, that will be 2.5000 5.200, 6.2000, and here 0.04952. Now again doing forward elimination. Phase, the equation will be 2.500 x1 plus 5.200 x2, that will be equal to 6.200, and the next equation will be 0.00392 x2, that will be equal to 0.04952. The value of, then solving the second equation, we will get the value of x2, that will be equal to 12.63265. Now putting the value of x2 in the first equation, this equation, we will get the value of x1, that will be equal to minus 23.7959. These are the values for the case 2. Now looking to case 3. The next matrix will be 0.2 e minus 4, 2.000, 2.000, 1.000, 2.000, and 4.000. The above matrix can also be written as 0.00002, 2.000, 1.000, 2.000, and 2.000, 4.000, as the e in the above matrix represents the exponential power of the variable. Now by Gauss elimination, we will perform the following operation on the matrix: R2 minus R1 into A21 upon A11. The diagonal matrix we will get 0.0002, 2.000, 2.000, 0, minus 99.998, minus 99.996. Now using forward elimination, method, the following equation will be formed: 0.00002 x1 plus 2.000 x2 equals to 2.000. In the next equation will be 0.99998 x2 equals to minus 99.996. The value of x2 we will get from solving this second equation, and this is the first equation. Now solving the second equation, we get the value of x2, that will be 0.99998, and putting the value of x2 in first equation, we get the value of x1 as 2.000 minus 1.99996 upon 0.00002. The value of x1 will be 2. These are the values of x1 and x2 in the case 3. Now we will look up to case 4, and will be performing the same operations as we have done in case 1, case 2, and case 3 to obtain the values of x1 and x2 in case 4. The given matrix in case 4 will be 1.000, 2.000, 4.000, 0.2 e 4, 2.000, and 2.000. Again by Gauss elimination, following the operation R2 minus R1 into A21 upon A11. The diagonal matrix which will be formed is this is the diagonal matrix which is formed after performing the elimination on the rows. Now using forward elimination phase, the equations which will be formed will be 1.0000x1 plus 2.0000x2 equals to 4.000. The second equation which will be formed is 1.99996x2 equals to 1.99992. This is the first equation in case 4 and this is the second equation in case 4. Now solving equation 2, we will get the value of x2 as 0.99998. This is the value of x2 in case 4, and putting this value in the first equation, we get the value of x1 as x1 equals to 2.00004. That will be approximately 2. So the value of x1 is 2. Now comes the question number A. In case 1, the values of x1 and x2 are x1 equals to minus 32.79451 and x2 is 16.9589. And in case 2, the values are x1 equals to minus 23.7959 and x2 is 12.63265. Hence, we can conclude that when the value of A22 is changed by 0.001, then the result displays a big change in their x1 and x2 values. Hence, we conclude when the value of A22 is changed by 0.0001, then the result display a big change in their x1 and x2 values. This was the first question, the question A. Now comes the question number B, that is the B part. And the B part says, how interchange of equation affects the solution in case 3 and case 4. In case 3, the values are x1 equals to 2, x2 equals to 0.99998, and in case 4, the values are x1 equals to 2 and x2 equals to 0.99998. Hence, we can conclude that the interchange of equation does not affect the solution of case 3 and case 4. Hence, the interchange of equation does not affect the values of case 3 and case 4. So this was the solution for the first question. Hope you have understood it. Thank you.